All right, guys, I have heard your request loud and clear to make more videos. So this section 9.2 that we learned in class, we did most of them in class and the rest I'm going to do in this video. I have left 4 problems for us to finish in this video. So here is 13. All right, so let's see, our equation is negative x squared minus 3. There is no middle term. There's no b here because we don't have an x. Remember, your a goes with the x squared, b goes with x, but we don't see an x, and then c would just be your constant. Basically, a constant is a number that is not attached to a variable. So let's fill this stuff in. A is going to be a negative 1. There is a 1 here. Don't forget about that. So a is negative 1, b is 0, and c is negative 3. All right, so we're going to plug this information into our equation that we've been using, which is negative b, negative 0, over 2 times negative 1. That's your a. 0 can't be negative, first of all. And even if we did try to apply this negative, 0 divided by anything at all is just 0. So our x value for this vertex is going to be 0. I can fill it in down here. And in order to figure out what the y value is, I need to plug 0 into the equation for x. It's the x value. All right. So back to this equation, I have y equals negative x squared minus 3. So I'm going to plug in 0. And I'll get y equals negative 0 minus 3. All right, again, there's no such thing as negative 0. So basically this is just 0 minus 3, which is negative 3. So our vertex is at 0, negative 3. Let's go ahead and plot that. I'm going to use a color just because it tends to show up a little bit better on the graph. Black pen, you know, on top of a black graph the lines will just mix up together. So 0, negative 3. 0 is here in the x-axis. It doesn't go left or right. And then down 3. So 1, 2, 3. Okay, so there's my vertex. And right away, I know that my axis of symmetry also, remember, it's going to go through the vertex, so it's going to be this line at x equals 0. All right, so let's find the other 2 points. Remember your list of steps from your notes. We need to use 2 ordered pairs to the right and plug them in, all right? So let's see, what do I have to the right of this point? If I go to the right, I could use 1 and then 2. Let's just use 1 and 2, it'll make things easier. So we'll make a table. Let's plug in 1 and plug in 2 and see what we get. These will be ordered pairs, all right? So if I plug 1 into this equation, I will have negative 1 squared minus 3. All I did was put 1 in where x is. So negative 1 squared minus 3. All right, so we need to square the 1 first and then make it negative. So this will be negative 1 minus 3. It's negative 4. Okay, and for 2, we'll have negative 2 squared minus 3. 2 squared is 4. Put the negative in front of it. Negative 4 minus 3 is negative 7. All right. So let's plot these 2 points. 1, negative 4. So 1, 2, 3. I'm sorry, I miscounted. 1, 2, 3, 4. And then we have 2, negative 7. There is a line here, by the way. There's not this big of a gap between them. It just didn't copy very well. So we're going to have 1, 2, right here, and then down 7. 1, 2, 3, 4, 5, 6, 7. All right. So if our axis of symmetry, remember, is at x equals 0, so that's basically on the y-axis, we need 2 more points. We're going to use symmetry to make 2 more points on the left side of the vertex. So we're going to mimic this point 1 space over this way to the left, and we're going to mimic this point. It is 2 spaces from the axis of symmetry, so I'm going to do 2 spaces over to the left. Okay, so do you see how they're in the same position? They're both 2 units away from this line. This one is both 1 units away from this line. So our last step is to make the parabola, connect it with a smooth, rounded bottom like this, and put arrows on the ends. Whew. Do another one, 14. Okay, again, we have x squared plus 2. That means no b. We don't have just a regular x, a linear x, okay? So x squared goes with a. There is a 1 here, so a is 1. B, again, in this problem is going to be 0, and c will be 2. So we'll plug everything in for our equation, negative 0 over 2 times 1, which is 0. So our x value for our vertex is 0. Plug it back into the equation to figure out what y is. So y equals x squared plus 2. Plug 0 in where x is. So y equals 0 squared plus 2. 0 squared is 0. Add 2 is 2. Okay. So our vertex is going to be at 0, 2. 0 and up 2. So right here is the vertex. And the axis of symmetry goes through this vertex. So again, just like in the last problem, axis of symmetry is where x equals 0. All right. Let's think about this for a second. A is positive, so that means it's going to be a smile. It's going to open up. Remember, positive things that happen in your life make you smile. So this is going to look something like this. And A is 1, so it'll be a normal size. It won't be wide. It won't be narrow. So let's see what happens here. Let's pick 2 values to the right and plug them in to get some ordered pairs. So here is my table. 2 numbers to the right of 0. I'm going to use 1 and 2 again. So 1 and 2. Always use 1 and 2. It's just easy if you can. All right, so we've got x squared plus 2. We're going to plug in 1 and plug in 2 and see what happens. So 1 squared plus 2, well, 1 squared is 1, add 2 would be 3. And then 2 squared plus 2, 2 squared is 4, plus 2 is 6. So we'll have 3 and 6. Let's plot these points. We are starting at the origin, over 1 and up 3. 1, 2, and 3. Over 2, 1, 2, and up 6. 1, 2, 3, 4, 5, 6. And let's use symmetry to reflect them over that axis of symmetry. So it's going to be here, and oh, looks like it's 2 away, so here. All right, connect with a smooth round bottom and add arrows. And there's our parabola. It does open up, it does smile. All right, let's do the last 2. We're going to do 17 and 18. All right, let's locate our numbers. We have ax squared plus bx plus c. All right, so we have our 3 numbers. A is 2, b is 8, c is 5. So let's plug in and find our vertex. We're going to use this equation. So negative b over 2a. Negative b is going to be negative 8 over 2 times a, and a is 2, so 2 times 2. All right, so we have negative 8 over 2 times 2, which is 4. And negative 8 divided by 4 is negative 2. So our x value for the vertex is negative 2. Let's take that negative 2 and plug it back into this equation and see what we get for y. Now be really careful when you have x squared. You need to do the squaring first and then multiply it by 2. Remember your order of operations, PEMDAS. Exponent comes before multiplication. Parentheses, exponent, then multiplication. PEM, P-E-M, okay? So we're going to do 2 and then x squared, so negative 2 squared, plus 8 times negative 2 plus 5. Okay. So I took this equation, and every place that I saw x, I took the x away and substituted in that negative 2. So we have negative 2 squared is negative 2 times negative 2, which is positive 4. Okay, so positive 4 times 2 is 8. No, yes it is. All right, plus 8 times negative 2 is negative 16, so minus 16. And then don't forget about your constant, plus 5. So let's do this math. 8 minus 16 is negative 8, plus 5 is negative 3. All right, so we have a vertex at negative 2, negative 3, and we can do the axis of symmetry right now. It's whatever your x coordinate is, so it's at negative 2. Remember, it goes through the vertex, so that just makes sense, doesn't it? Okay, vertex. -2, -3. So start at the origin. -2 and down 3. 1, 2, 3. There's the vertex. Okay, I'm looking at A, and it's positive, so that means it's going to smile, but it's 2, so that means it's going to be narrow. We should have a really narrow parabola, so we got to be careful with this one. All right, give me two numbers that are to the right of this place, which is going to be -1 and 0 maybe. So let's do our table with -1 and 0. Plug these two numbers into this equation. All right, so we have 2 -1 squared plus 8 times -1 plus 5. Okay. So -1 squared is 1 times 2, which is 2. 8 times -1 is -8, and then plus 5. 2 minus 8 is -6, plus 5 is -1. So this point will be at -1, -1. How about 0? 2 times 0 squared plus 8 times 0 plus 5. It's really nice when your x value is 0, because when you plug it back in, I hope you're noticing something. These first two end up not mattering, because anything times 0, if x is 0, anything times 0 is gone. Same thing here, 8 times 0, that's gone. It's always just going to be whatever your constant is. So let me show you what I mean. 0 squared is 0. Times 2 is still 0. So you have 0 plus 8 times 0, 0 plus 5. Okay, 0 plus 0 plus 5 is 5, which is just what the constant was. All right, let's graph these points. We are at -1. So here's -1, -1. And then 0, 5. 1, 2, 3, 4, 5. All right, let's mirror everything over the axis of symmetry. The axis of symmetry is this line right here, okay? So it's one space away from that line on this side, and then this one is 2 spaces from that line on the other side. All right, very narrow parabola, which is what we thought we would get. Okay, last one. This video is getting pretty lengthy, so let's try to fly through this. All right, we have to find our 3 values. We have A, B, and C. So A is 1, B is -4, C is 8. So let's plug everything in. -B, -4. What happens with a double negative? It becomes positive, okay? 2a, 2 times a is 2 times 1, which will just be 2. 4 divided by 2 is 2. So the x value of our vertex is 2. Let's plug that in and get a y value. So we're going to take this equation, and wherever we see x, we're going to plug 2 in. So 2 squared minus 4 times 2 plus 8. 2 squared is 4 minus 4 times 2, which would be 8, plus 8. All right. So you can do this math, go ahead, just from left to right, or think about it for a second. -8 plus 8, what happens there? 0. So really, we're just going to end up getting 4. And if you want to do it, we can go ahead and do it. 4 minus 8 is -4, plus 8, 4. Okay, you can do the math that way too if you'd like. All right, axis of symmetry is wherever your x value is because it goes through the vertex, so x equals 2 would be your axis of symmetry. Let's graph our vertex. Over 2, 1, 2, and up 4. 1, 2, 3, 4. There's the axis of symmetry. Okay, our A is just 1. It's positive, so this is going to be a smile, and it should be normal because it's 1, okay? We need an x and y table. Let's see, I need 2 numbers that are to the right of this point. This point is at 2, so I guess we could use 3 and 4. Why not? All right. All right, 3 squared minus 4 times 3 plus 8. So 3 squared is 9. 4 times 3 is 12 plus 8. 9 minus 12 is -3, plus 8 would be 5. Okay. Now let's do it with 4. 4 squared minus 4 times 4 plus 8. 4 squared is 16 minus 4 times 4 is, again, 16 plus 8. 16 minus 16 is 0, plus 8 is 8. All right. Let's graph our other 2 points and then use symmetry. So we are at 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. And then 4, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Use symmetry to mirror them to the other side of the axis of symmetry. So here and here. Connect our lines. Don't forget your arrows. And that'll be the parabola for that problem. All right, guys. I will see you in class.